Hello students, good evening to all of you. So here I'm going to discuss a problem from the Lagrangian and Hamiltonian approach, classical mechanics. So here we have a bead on a smooth rod, which rod is being rotating with the one fixed end with uniform angular velocity omega in a vertical plane. Find the Lagrangian and hence the equation of motion. So first of all, we simply take draw the diagram there. So let's suppose this is our x and this is our y. So students, let's suppose this is some rod having being attached. One end is being fixed there. This is attached to there. So this rod is being rotating with angular velocity omega in a vertical plane there. So here on the rod we have a bead that is sliding on the bead that is being sliding. Oh, sorry, on the rod there it is given in the question. Bead is sliding on the smooth rod. This rod is smooth, so there will be no friction there. So let's suppose r is this the position there and this angle is basically theta, let's suppose. So this is rod is basically rotating in a vertical plane. ये एक vertical plane में rotate कर रहा है like that. It means that motion is being basically in the this xy plane. This is not a horizontal plane, this is a vertical plane. So this is rotating like that in a vertical plane. So let's suppose these are the positions. So whenever we are going to write the expression for Lagrangian, we know that the L is equal to T minus V. So first of all, we'll just write the expression for kinetic energy term and the potential energy term there. So kinetic energy, as it is basically a rotational as well translation there. So we'll simply write the expression for kinetic energy as half mv square plus half I omega square. It is rotating with the uniform angular velocity omega in this vertical plane. So we'll simply solve this half mv square and plus in place of this I we can simply write that m into r square. Let's suppose this is our bead there. This is the bead having this position r. Again I draw this is bead. So it is mr square for the moment of inertia, I term there. And like in place of omega, students, we know that omega is basically d theta by dt. So we simply write in place of omega as theta dot square. This is theta dot square. And further simplifying, this is half m को हम कॉमन ले सकते हैं. In place of v square I will simply write r dot square plus this is basically r square and theta dot square. So this is the kinetic energy term for this particular case of this motion. And then simply write the potential energy term. So like this position, and if we talk about this motion is basically entirely in this xy plane. So this height is basically r sine theta. This is r sine theta. We can use the trigonometry there. So basically this is perpendicular. So this is the like sine theta is equal to perpendicular upon r. So यहाँ से हम p निकाल लेंगे, that is r sin theta. So potential energy is simply students mg r sin theta. So this is the term for the potential energy. So then after we simply write the Lagrangian. First of all हमसे Lagrangian पूछा गया है, so we'll write the expression for Lagrangian. So Lagrangian is equal to t minus v. So we'll write the expression as half m r dot square plus r square theta dot square minus v. We know that it is mgr sin theta. So students, this is the expression for Lagrangian. Then after Lagrangian हमसे ये भी पूछा गया है, we have to write the equations of motion there, Lagrangian equation of motion there. We know that the Lagrangian equation of motion as curly L upon curly R minus d by dt of curly L upon curly R dot is equal to 0. And similarly the other equation is curly L curly theta minus d by dt of curly L upon curly theta dot is equal to 0. So these are the Lagrangian equations as we already derived the expression for L. So from here we can simply do this curly L upon curly R. So the value of curly L upon curly R, students, like this is your R, this is R term there. Just a minute. This is that term R. So we'll write the expression for, first of all we'll write for curly L upon curly R. So यहाँ से हम curly L upon curly R निकालते हैं like 2 into this. So 2 से 2 cancel हो जाएगा. So simply I hope आप curly L upon curly R निकाल सकते हो. It is basically mr theta dot square minus like this is a mgr sin theta. We are writing the curly L, sorry, we have curly L upon curly R. R is also there in this term mgr sin theta. So we'll simply write it as minus mg sin theta. So this is the value of curly L upon curly R. And like this is the expression there, minus d by dt of लाइक अगर हम अपना करली एल अपॉन करली आर डॉट को देखें स्टूडेंट्स, हियर वी हैव ओनली आर डॉट। सो इसका जो करली एल अपॉन करली आर डॉट आएगा, करली एल अपॉन करली आर डॉट आएगा, दैट इज 2 mr डॉट स्क्वायर। यहाँ पर बाकी 2 भी है, सो 2 से 2 जो है वो कैंसिल हो जाएगा। वी आर सिंपली गेटिंग mr डॉट, सो दिस इज mr डॉट। सो आप करली एल अपॉन करली आर डॉट की जगह लिखोगे mr डॉट। सो दिस इज अवर फर्स्ट इक्वेशन ऑफ मोशन, लैग्रेंजियन इक्वेशन ऑफ मोशन। एंड देन ये सेकंड वाली है विद रिस्पेक्ट टू थीटा, इसे भी हम सॉल्व कर लेंगे। This is curly L upon curly theta. So here we have the theta there only in this term. This is basically theta dot. So we have to differentiate this theta only there. So यहाँ से इसको सॉल्व करने पे हमारे पास आएगा साइन थीटा का कॉस थीटा होगा, लाइक इट इज सिंपली माइनस mgr cos theta. So curly L upon curly theta का वैल्यू है स्टूडेंट्स माइनस mgr cos theta. Then माइनस, यहाँ से आगे चलते हैं, इट इज डी बाई डी टी। देन वी हैव टू राइट द एक्सप्रेशन फॉर करली एल अपॉन करली थीटा डॉट। सो दिस इज द टर्म थीटा डॉट देयर। सो इसका वैल्यू सिंपल है, लाइक 2 से 2 कैंसिल हो जाएगा व्हेन वी डिफरेंशिएट दिस। सो यहाँ पर इसकी जो वैल्यू आएगी हमारे पास वो सिंपली आ जाएगी एम आर स्क्वायर थीटा डॉट इक्वल टू 0। सो दिस इज फॉर दिस curly L upon curly theta. This is curly L upon curly theta का वैल्यू है mr square theta dot equal to and लास्ट में 0. So these are the equations of motion there, Lagrangian equation of motion. Thank you.